Good day, everyone. Today's topic is number system session part 2. So, last class, what you have discussed. So, we have discussed about number system. We have discussed about the conversion of a decimal number into binary, octal, and hexadecimal, and conversion of binary, octal, and hexadecimal to decimal number system. So, we have seen both integer, that is fractional, and non-fractional conversions. So today we will be discussing about conversion of a binary to octal and hexadecimal, how the conversion of a octal and hexadecimal to binary. Then we will be discussing about addition and subtraction in binary system, how signed and unsigned numbers are used in the number system. Then what are the binary coding schemes we will be seeing it today. So first we will see how a binary number is converted into octal and hexadecimal. That is, we are going to convert base 2 to base 8 and base 16. We are going to convert it to these two formats. So this is all. So we will see the shortcut method, then the general method. So what is the shortcut method is, in the octal binary system, we are going to use 0 to 7. That is only 8 symbols we are going to use. So that 8 symbols can be represented using how many combinations of binary system. That is, we are going to have only 0 and 1. So with 2 power 0, I can represent only one number. Okay. With the combination of two digits, that is, I can take it as 0, 0, 0, 1, 1, 0, 1, 1. So I can use four numbers to be represented using these numbers. So I can have four letters can be represented. But in octal, we have about 8 combinations. So we'll be using 2 power 3 for 8 letters. So that is from 0 to 7 can be represented using 2 power 3. That means 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. So with a 3 digit or 3 bits combination, I can represent 8 numbers. So this is the meaning. So this is how many bit combinations we are going to consider, that is taken care. So an octal digits is from 0 to 7 can be represented as combinations of 3 bits in a binary system. Similarly, in hexadecimal, we have digits from 0 to 15, that is 16 characters or 16 symbols are there. So we can use a combination of 4 bits to represent 16 characters. So we'll be using 2 power 3 for octal, that is 8 bits, and 2 power 4 for 16. That means 3-bit combination for octal and 4-bit combination for hexadecimal. Okay, so how do we convert it? Okay, so what are the steps we are going to convert? So the first step is the binary numbers are divided into groups of 3 bits. Okay, so individual bits are going to be we are going to convert it into 3 bits combination starting from rightmost side. Okay, from right side to left side, we are going to form a 3-bit combination. For each 3-bit combination, we will find its octal number, and the result will be the combination of octal number. If it is going to be an hexadecimal conversion, the binary numbers are going to be grouped in terms of 4 bits. Okay, so we will be combining with the terms of 4 bits here starting from rightmost side. So each 4 bit will represent a single hexadigit number. So the combination of all the 4 bits combination is going to be the hexadecimal number. So the combinations will be an hexadecimal number. So let us see an example. So I am going to have this number. Okay, so 111, so 111, 01, 01, 100, 110. So what I'm going to do is I'm going to convert into octal. So I will take only 3 groups. So let me take it as a 3 groups here. So I have divided the numbers into 3 groups. So I will take one sec. So let us take a 3-bit combination from rightmost. So it is going to be 110. the second combination is 110, then third one is 101, okay, and this next one is 110, and finally you will have only one as a sub number. So I have written this. Now these numbers has to be converted into octal. So if you remember the table, you can easily do it, or else what you have to do is each 3-bit number you can convert it into. So I will take the first number, so 110, so 011 into 2 power 0, 2 power 1, 2 power 2, so which will be 0, 2, 4, which is 6. Okay, so you have a 6 over here. Similarly for 110, it is going to be 110, so it is 0, 0, and this will be of 4, so you will be having only 4 over here. And similarly for 101, 101, it is into 2 power 0, 2 power 1, 2 power 2, so which is 1, 0, 4, so it is equal to 5, so you have 5 over here. And for 110, 011, it is 2 power 0, 2 power 1, 2 power 2, so that will be 0, 2, 4, it is again 6, so this is going to be 6. And finally this is single 1, so 1 is 1 into 2 power 0, which will be equal to 1, so that is the answer for 1. So each 3-digit bits you just convert it into a decimal number, and that decimal number will be an octal representation. So this is the shortcut for converting a binary number into octal number system. Similarly, if you want to convert the same binary number into an hexadecimal number, so take 4-bit combinations. So from the rightmost, take 4-bit combinations. It's going to be 011, again it is going to be 011, and then it is going to be 1101. So let us see for each one. So it is going to be 0110, so just take it the same way. So 0110 into 2 power 0 into 2 power 1 into 2 power 2 into 2 power 3. So that will be equal to 0, 2, 4, and this is 0. So answer is 6. So for this and this, it is 6. Similarly for 1101, so 1011, it is 2 power 0, 2 power 1, 2 power 2, 2 power 3. So you will get 1, 0, 4, and this will be 8. So it is 13. We don't have number 13 in hexadecimal, so 13 will be represented as D over here. So it is taken as D. Finally, it is 1. So the final answer for the given binary number is octal is 16546, and for hexadecimal is 1D66. Okay. So I repeat again how to convert a binary number into octal. Divide the binary number bits into 3-bit combination from the right side towards left side. Convert each 3-bit into decimal number, and that decimal number combination will be the octal number system. Similarly, if you want to convert a binary number into hexadecimal, group it into 4 bits from the right side. Okay, form a group of 4 bits from the right side and convert each 4-bit combination into a decimal number, and that will be equivalent to the hexadecimal number. I repeat again, if the value is greater than 9 for the decimal value calculation, then you have to use the representation A, B, C, D, E, because from 0 to 9 only we have the symbols. After that, from 10 to 15, it will be represented as A to F. So this is for 10 to 15, it will be A to F. So if you get 13, it will be converted into D. Right. So next we will see how an octal and hexadecimal can be converted into a binary number. So the conversion of octal to a binary number, the steps is, so convert each octal number into 3-bit, okay, binary numbers, okay, 3 digits binary number. Okay, so what you will do is each digits will be converted into a 3-bit binary number. Okay, that is the meaning of this. Each digit is converted into 3-bit binary number. Okay, so this is how we will be doing. The same way in hexadecimal, each number or each digit will be converted into 4-bit binary number representation. So we can understand how it is going to be done. Let us see an example. Now we are going to convert 473 of base 8 to of base 2. Okay, so what I'm going to do is I'm taking each bit. So first for 3 you divide by 2, so 2 of it is 1 of 1, again 2 of 0, it is going to be 1. So 3 is represented as 0 1 1. Similarly take for 7, so 7, 2 into 3 is 6, okay, it is of 1, then 2 into 1 is of 1, then 2 power 0 is of 1. So 7 will be represented as 111. Similarly, take for 4. So 4, 2 power into 2 it is 4. So remainder will be 0, and 2 into 1 it is remainder 0. So it is of 2 0, it will be 1. So 4 is represented as 100. Now you can combine 473 into this number format. So it will be represented as 100 for 4, and 111 for 7, and 011 for 3. So this is how you will convert. Take each digit, divide by 2, convert it into a binary number, and combine all the numbers as per the digit order. Then you will get the number. So this is how an octal number is converted into binary number. Similarly, let us take how an hexadecimal is going to be converted. So let me rub this so I can write it over here. So now we are going to convert 2BA3 to some binary numbers. Okay, so we are going to convert this 16 hexadecimal number into. So what is 3? We have already calculated what is 3 over here. So 3 is, so for hexadecimal I will do like this. So 3 it is 1 of 1, again 2 0 it is 1. So this you have to write it as 0 1 1. Only 3 bits are there, but you have to write it in 4 bits. So write it as extra 0 should be added in the leftmost. Okay, keep that in mind. So this is 0 1 1 for 3. Similarly for A is nothing but 10. So 2 5 times it is going to be of 0. 2 2s are 4, it is of remainder 1. 2 1s are 0, it is of 1. Again 2 zeros are 0. So now A is going to be represented as 0. Sorry, here it is 1. Okay, so it is going to be represented as 1 0 1 0. Similarly for B is 11. 1, 2 into 2 is of 1, and 2 1s of 0. Again you can divide by 0, this will be of 1. So 4 bits, so B will be of 1 1 0, sorry it's 0 0 1 1. Okay, similarly for 2 1s are 0, and it is of 2 0 of 1. So 2 is represented as 0 1 0. So you have only 3 bits, so 4th bit is going to be 0. So your final answer, what is for 2? It is 1 0. Okay, you can avoid the first 2 digits. Then B is 1 0 1 1, and A is 1 0 1 0, and 3 is 0 0 1 1. So this is for 3, this is for A, and this is B, and this is 2. So this is how an hexadecimal number is converted into a binary number. So I repeat again, if you want to convert a binary number into octal, divide the binary numbers into 3 bits from right side to left side. Convert each 3 bits into decimal number, that will be your octal number. Similarly, if you want to convert a binary to hexadecimal, group into 4 bits from right side to left side. Convert each 4 bits into a decimal value, and that will be the hexadecimal number. If the decimal value is greater than 9, use the alphabet characters A to F for representing 10 to 15. Okay, this is conversion of binary to octal and hexadecimal. Now, what is the conversion from octal hexadecimal to binaries? Each digit in octal has to be represented in a binary format. Take each digit, divide by 2 and bring it to 3-bit combinations. Okay. So if you have a 473, 3 has to be converted into 3-bit combinations, 7 has to be converted into 3-bit combinations, and 4 has to be converted into 3-bit combinations. So just divide it by 2. Similarly, an hexadecimal can be converted into 4-bit binary number. So take each digit, divide by 2 and bring the answer into a 4-bit combination. So that is the example for 1. So you can see here, this is how it is converted. So the next thing we will see is about binary arithmetic. So in binary arithmetic, what will the basic operation we are going to perform here is addition and subtraction. So we have division and multiplication, so which I leave it to your end as a beyond your syllabus. So we will see what is binary addition and binary subtraction. Okay. So each bit in a unit column from the rightmost to the towards leftmost will be added up using binary addition rule. Simple. For example, if it is 101, which has to be added with 1 1. So this is how I have to add two binary numbers. Okay. So what is unit column is? This is the first unit column, this is second unit column, this is third unit column. So this is 1, this is 2, this is 3. Each unit column must be added up with the same unit column in the second number also. So this is 1, this is 2, this is 3. So each unit column must be added. Simple. 0 1 1 1 0 1 1. So each bits will be added up using binary addition rule. Similarly, you will also carry out the same thing for the subtraction also. So in addition, you may have a carry bit. In subtraction, you may need a borrow bit, just like that. Okay. So how you perform an ordinary addition and subtraction in decimal, the same way we will be doing it in binary also. So when you add it up, you may have a carry over for the next column. Okay. Sometimes if you want to delete, if the uppermost column, if the uppermost row is smaller, you try to borrow from the next column for its subtraction purpose. So let us see how it is done. So let us see the first binary addition. So this is binary addition rule. So this is for two input. If 0 and 0 is added, you will have 0. If 0 and 1, you will have 1. 1 and 0, you will have 1. If it is 1 and 1, that is 1 plus 1, you will get 1 0. Here 0 is the sum and 1 is carry. So that is what it is represented here. So the in a same column, if you have like this, it will be 1 plus 1, it will be 0. Okay, one second. Okay, so have it like this. So it's a 0 1 0 1. I am going to add. Okay, so 1 plus 1, it is 0 and the carry is 1. So this I represent it as carry. Okay, again you can add all these three inputs. 1 plus 0 is 1, 1 plus 0 is again 1, so it is going to be 1. So the answer is 1 0. So same thing, how three inputs can be added up. So that is given in this binary. So let us see an example so you will understand how a binary addition can be carried out. So first I am going to add 1 0 and 0 1. So 1 0 0 1. As I said, for 1 plus 1 the answer will be 0 and carry will be 1. So 0 1 answer is 1, 1 0 answer is 1. So 1 0 2 plus 0 1 2, the answer is 1 1 2. Now you will take 0 1 1 1. Now when 1 plus 1, you will get 0 as answer and 1 is the carry. So we'll take 1 to the next column, the topmost. Now it's a 3-bit combination. So 1 plus 0 is again there, up to this it will be answer is 1. Then 1 plus 1 is 0. You have 0 and you will have a carry over top. Now it is not any other value is not there, so you can just bring it down. So you will have the answer as 1 0 0. It's similar to your addition only. Okay, so what is written here is it's a carry over. So 0 1 plus 1 1, the answer will be is 1 0 0 2. Similarly, we'll do for 4 bits. So 1 0 0 1 1. So let me write it over here 1 0 0 1, and you are going to add 4 ones over here. So 1 plus 1, it is 0. You have 1 over the carry. Again 1 plus 0 is 1. So 1 plus 1, again it is 0. 1 is carry. 1 plus 0, again 1. So it is 0. Again 1 is carry. 1 plus 1, here answer will be 1 plus 1. Answer is 1 0. 1 is carry. Again, so 1 will be a carry. Again 0 plus, again 0 plus 1 is 1. So you will have 1 over here, and this 1 carry will come over down. So the answer is 1 1 0 1. So this is the answer for performing addition. So let me have another example for you. 1 1 0 1 0 1 0 0. Okay, so now if this is the answer, so 1 plus 1, it will be 1. 0 plus 0, it is 0. 1 plus 1, it is 0, and the carry will be 1 over here. So it is 1 plus 1 0, carry is 1 over here. Again I'll keep the 1 over here. 1 plus 1, it is 0, carries over. 0 plus 0 is 0 0. Then finally you bring 1 over here. So this is the answer for these two numbers. So this is how binary addition is carried out. Okay, I hope I have given enough example for binary addition. If you have doubt, we will have another session to do all the exercise. Right, next we go for a binary subtraction. So how do we subtract it? So if it is 0 minus 0, you will have 0. If it is 0 minus 1, okay, what I have to do here is I should borrow 1. Okay, so what happens is it will borrow 1 over here. So I will borrow 1. So I will borrow 1. So it becomes 1 0 now. Okay, so if you subtract 1 0, you will get 1 as your answer. How is it, sir? Because 1 plus 1 is 1 plus 1 is 1 0. So the reverse process is 1 0 minus 1 is 1. So that is the concept we are doing over here. Next thing is 1 0 minus means you will have 1 alone. Okay, and if it is 1 minus 1, it will be 0. So this is what done. If the topmost row is smaller, then so let us see an example for binary subtraction. So we are going to subtract 1 0 from 0 1. Okay, so I will do one by one over in the top so you can understand how it is done. Okay, so we are going to subtract 1 0 from 0 1. Okay, so what happens is, so 0 cannot be subtracted by 1, so it has to borrow. So this will become 0 and this will become 1 0. So when you subtract 1 0, you will have 1. 0 minus 0 is 0 1. So that is the answer over here. So previous 0 is striked out here and it becomes 1 0, and you will subtract over here. Similarly 1 1 1 1, I am subtracting it. If you subtract, it will become 0 0. So the answer is 0 0 over here. Now the next example is I am going to subtract 1 1 0 1. I am going to subtract with 0 0 1 1. So this is the one answer I am going to subtract it. So let me take it to the top. So we'll see how addition happens. 1 minus 1 is 0, but 0 it has to borrow, so it will borrow here. It becomes 0, and this it will become 1 0. So 1 0 minus 1 is 1. 0 minus 0 is 0, and 1 minus 0 is 1. So the answer is 1 0 1 0. So this is how binary subtraction is done. So let me have another example. So 1 0 1 0, I'm going to subtract with 0 1 1 0. Okay, so I'm going to subtract with 0 0 minus 1. So when I subtract, so you will have 0. 1 minus 1 is 0 0. So what happens is this 1 will become 0 and this will become 1 0. So 1 0 minus 1 is 1, and you can get the answer is 0. So this is the answer. So how to verify that my answer is correct? You just add these two numbers to get the next two numbers. That is simple. I will consider only the answer and the subtracting number alone here. So what I do is I take this number and this number. So 0 1 1 0 0 1 0 0. Just add it up. So you will get the first number. Okay, so you will have 0 1, this 1 plus 1, it is 0, again you will have 1 over here, then it is 1 0. You can see after subtracting you can, so you can verify your answer by in this way to check your binary subtraction whether you have done it properly. So addition, if it is 1 and 1, the extra bit will be carried over to the next column. The addition will be carried out from the rightmost column towards the leftmost column. If the number is having carryover, that carryover will be taken to the next column of the left side. Okay, now if it is a subtraction, we will subtract from rightmost column towards the leftmost column. If the subtraction needs is if the topmost row is smaller value, that is the top value is smaller and the bottom value is bigger, the top value will borrow the number from the left column. Okay, to the very next column you will borrow the number. So in addition, you will have a carry will be given to the next left column. If it is a subtraction, you will borrow a number from the very next left column. So that is binary arithmetic operation, addition and subtraction. Next we will see how positive numbers and negative numbers are handled in binary system. So a binary number, it can be either of positive or negative. So in binary system, it consists of n bits. In n bits, there are two parts are there. One is sign bit, another one is a magnitude bit. So the leftmost bit, okay, so we call it as the leftmost bit as a MSB, the most significant bit. So that most significant bit is used for sign bits. If it is 0, it represents positive number. If it is 1, it represents negative number. So see the example. So here in this example, the leftmost bit will represent the sign bit. So if it is 0, then 11000011 is a positive number. If it is 1, then 11000011, that is this number, is a negative number. So you will use sign bit 0 for positive number and you will use sign bit number 1 for negative number. So if you are using an 8-bit signed number, each 8-bit numbers, that is 2 power 3, it can represent, okay, so 2 power 8, it can represent total 256 characters, okay, 2 power 8. So I am using 8 bits. So 2 to the power of 8, I can have 256 combination. If you have 256 combination, how many numbers for positive numbers and how many for negative numbers? So I will have 128 negative numbers and I will have one number for 0 and remaining 127 for positive numbers. Understand? I use 8-bit combination. That means 2 power 8 combinations I am going to use. I will have 256 combinations. In that I have 128 for negative numbers, one number for 0 combination and 127 for positive numbers. So that is how, hence it is ranges from minus 128 to minus 127. Okay. Suppose if you are using 8-bit unsigned numbers, that is I am using only positive numbers, then you will have 0 to 255 because one number has gone for 0. So the remaining numbers is 255. So you will have 0 to 255. That is total 256 combinations you use for unsigned numbers. Okay. Now how do we handle signed and unsigned numbers in our binary system? So we will be using a new term called complement. That is complement of binary numbers. So the binary system has two complements. One is ones complement, another one is twos complement. Very simple topic. What is ones complement? Convert each bit 1 to 0 and 0 to 1. That is, in ones complement, 0 will be converted into 1 and 1 will be converted into 0. Simple. If you have 1001, okay, then it's ones complement. That is, ones complement is convert everything into 0. So 0 1 1 0, each bit is converted into 1. So the first one is converted into 0, the second 0 is converted into 1, the third one is converted into 1, and finally it is converted. So we just convert zeros into 1 and ones into 0, and that is called ones complement. Okay, so I have given an example. You can see 101 is converted into 010, 1011 is converted into 0100, and 101100 is converted into 001 0011. So this is ones complement. So understand what is ones complement is. Ones complement is very simple, converting 0 to 1 and 1 to 0. Now what is 2's complement, sir? Okay, for any number, convert that number into 1's complement and add 1 to it. Okay, just adding 1 to it. What is 2's complement is? Okay, just adding 1's complement. The 1's complement of the number is added with 1. For example, if I am taking 1001, then the 1's complement is 0110. Then what will be 2's complement is, for 0110, you just add one more number, you will get it as 0111. So for the binary number 110, the 1's complement is 0110 and 2's complement is 0111. So what I did here, I have just added 1 to the 1's complement of the number. For example, you can see here for 101, the 1's complement is 010. I just added 1 and this is the answer for 2's complement of 101. Similarly, for this number, I just added 1, so it has become 2's complement. And for this number, this is the 1's complement, I added 1 and this is the 2's complement for the given binary number. Okay, so why do we use 1's complement, 2's complement? Is the 2's complement is mainly used to represent negative values. Okay, so you will be using negative values to represent the binary numbers. Right, next we'll see how this 1's complement, that is how the signed numbers and unsigned numbers are used in fixed point representation. Right, so fixed point number representation is, suppose if the integer, if you have a positive integer binary number, then the signed bit will be 0 and the magnitude positive will be a magnitude positive number. Simple. If it is plus 18, the plus alone will be represented as 0 and 18 will be represented as an ordinary binary number here. So what is that binary number is? So this is the binary number. So here the positive number is represented as 0. Okay, and the remaining numbers are represented as a normal process. So this is for positive numbers. Now what is about for negative numbers? Okay, so negative numbers can be represented in three ways. One, I can use it with a signed magnitude representation. Okay, simple. The plus and minus symbol alone will be represented as 1. So this is 1 and this is the representation of 18. Okay, you can see the same value I am using over here for 18. Okay, so that is the representation. So simple, only I will use a bit for representing my signed values. Okay, the second way is using 1's complement. Okay, so I can use 1 for a negative value, that is for this minus I use 1, and 18 is converted into 1's complement. So this is the 1's complement of the previous 18 value. And the third way is I can use 2's complement. So the 2's complement is, the minus will be 1 and 18 will be represented in 2's complement form. Okay, 18 will be represented. So a negative number in binary system can be represented with signed magnitude representation, or it can be used as a signed 1's complement, or it can be used as a signed 2's complement representation. Right, so let us see how addition and subtractions are done with signed numbers. That is, a positive or negative number can be added, or positive or negative number can be subtracted. How? Let us see how it is going to be performed. So addition of signed binary numbers. So here what we are going to do is, the positive numbers will be represented as signed magnitude representation. So this is signed magnitude representation. That is, you use only 0 or 1 to represent 0 for representing the positive numbers, and the remaining numbers represents the exact binary value of the decimal value 5. To represent the negative numbers, we will be using 2's complement form. Okay, so the minus will be of 1 and the remaining terms will be of this form. So we will just add these two numbers, and to find what is the answer, we will avoid adding up the signed bit. Okay, so simple, I just add these two numbers alone for my adding of positive and negative numbers. So we'll see an example, you will come into clear picture and clear understanding. I'm going to add positive and negative numbers in the binary addition. So you can see here I am going to add two positive numbers here, 5 and 10. So first 5 is converted into 4-bit combinations and I am adding it. So this is 0 1 1 0 and this is 1 0. I'm just adding it. So you will have 4 ones. So what is 4 ones? It is 15. So you can see it's a both are positive numbers, so it will be also of positive number. So you can write the answer as 4 zeros and 4 ones of 2, which is of positive number. Now let me add a positive number and let me add a negative number to the positive number, that is minus 5 plus 10. Okay, so what will be your answer? If it is minus 5 and plus 10 means it will be plus 5 will be your answer. So we'll see how it is done. First thing, how 5 should be represented. So minus value, it should be represented in 2's complement. So let me write what is 5 first. So what is 5 divided by 2? It is 2 power 2 1, 2 power 1 it is 0, it is 2 power 0 it is 1. So 5's binary representation is 0 1 0 1. What is 1's complement of 5? 1 0 1 0. What is the 2's complement of 5? You have to add plus 1 to this, so you will have 1 0 1 1. So this is the representation for number. So when you are performing signed binary number addition, every number should be represented as a 4-bit 8-bit combinations. So it has to be represented as a 8 bits. Okay, so what I will do here is, so it is an 8-bit combination, so I am going to write it. So 5 will be represented as 0 0 0 0 0 1 0. Okay, so the ones complement is 1 1 1 1. Okay, sorry, it is 1 0 1 0. And what will be the 2's complement? 1 1 1 1. You have to add plus 1 to this, so you will have 1 0 1 1 here. So this is the minus 5 for 2's complement representation. So I have used minus 5 for 2's complement here, and I have just added up the performance. So when you add it up, it will become 1 plus 0 is 1, 1 plus 1 0 is 0 1. So you will have a carry over 1 here, and 1 will be coming up. Again it is 0, so you will have a carries over here, and finally you will have a carry over here 1. Okay, so when you add 1 plus 1, it will become 0, so it becomes positive. So you can see here it is going to be 0 0 0 0 0 0 1 0 1. So what happens? It is a positive number 5. You can see the number value is positive 5. So next thing is I'm going to add plus 5 and minus 10. So first we will find out what is the 2's complement for 10 is. So what is 10? 10 will be 0 0 0 0 1 0 1 0. So how to do that, sir? You can just divide by 2. 2 divided by 5 is 2 0. 2 2s are 4, it is 1. And 2 1s are 0, it is 0. So the answer is 1 0 1 0. This 4-bit has to be converted into 8 bits. So you will have extra zeros in the left side. So this is the number, and we added extra bits in there. Now what is 1's complement for this? It will be 1 1 1 0 1 0 1. What will be the 2's complement? You just add plus 1 to this, so you will have, that is the 2's complement. So the 2's complement will be 0 1 1 0, then you will have 4 ones. Okay, so this is the 2's complement of 10. So just add with this number. So you know plus 5 plus minus 10 will be equal to minus 5. That means if the negative value is bigger, you will get the negative answer. If it is negative answer, your answer will be in 2's complement form. Always understand, if you are having a negative value, that is 5 plus minus 10 means the answer is minus 5. The result is negative value. It will be in 2's complement form. So what I do is, I just given here, I just added it. So just add the numbers. So it will be 1 0, it is 1 1 0 1. So you will get 1 1 1 0 1. So add the bit also. So when you add the bit, it will be also 1. So it represents that it is a negative number. So the number result which we got is a 2's complement form. It is of 2's complement. Okay. If you want to know what is the decimal value, convert this 2's complement into 1's complement. Okay. You convert it into everything. So what you do is just make a how to convert 2's complement into decimal form. 1 1 1 1 0 1 1. So this is 2's complement. Okay, so first subtract 1 here. It becomes 0, 1, 0, 1, 1, 1, 1, 1. Okay, now take 1's complement for this. So the 1's complement will be, just 1 second. So for the result answer here, it's in 2's complement form. Just subtract 1, you will get one value, that is 1's complement. Take 1's complement of this number, then you will get the answer. So this number is triple zero, sorry, double zero double zero, 0101. So which is of answer 5. So here my sign bit is 1, so it is going to be -5. Okay, so this is the answer. This is how you will get. See the next answer. I'm going to subtract. So the next number is, I'm going to take -5 and -10. So -5 is also in 2's complement and -10 is also in 2's complement. You just add it up. Okay, so it will result in minus value, because -5 plus -10 is going to be -15. So again you will have in 2's complement form. So take this number, subtract 1 from this and convert it into my 1's complement, you will get the final answer. So this is how an addition is performed in signed binary number. Okay, so next thing we will see about how a subtraction is carried out in signed binary numbers. So usually the subtraction will be performed in the replacement of addition. Okay, so if you are having a subtraction, that will be converted into addition operation. So you can see here. So here minus a and minus b. Okay, so here minus, so what I do is the minus will be taken inside and plus will be taken out, so it becomes minus a plus minus b. So subtraction is converted into an addition. Similarly, I have plus a plus b, so take this plus inside and bring this minus plus outside, so minus inside and plus outside, it becomes a plus plus minus b. Similarly, if you have a minus, minus means these two will be converted into plus. Okay, I will convert these two into plus, and again these two will be converted into plus. So this is how you will perform subtraction of signed binary numbers. So let us see the first example. I am going to perform -5 subtracting with +10. Okay, so what I have to do is I have to convert. So what I will do is I will convert it like this: -5 plus -10. Okay, so I have taken minus inside and I have brought plus inside so that I can perform it easily. Now you can see 5 is in negative form, 10 is also in negative form. So what is for 5? So what will be for 5? 5 is divided by 2, 2 2s are 4, it is 1, 2 1s are 1 0, and again 2 2s are 0, it is 1. So 5 will be represented as 4 zeros followed by 0 1 0. And for having -5, I have to convert this into 1's complement. So what is the 1's complement for 5 is 1 1 1 1 1 0 1 0. And what will be 2's complement? I have to add plus 1 to this and I have to get the answer. So the -5 will be 1 1 1 1 1 0 1 1. So this is the answer for -5. Similarly for 10, okay, so you can have 10 over here. So 2 5s are 10 0, 2 2s are 4, it is 1, 2 1s are 2, it is 0. Okay, so it is 1 0 1 0. So it has to be represented as 8 bits, so have 4 zeros before. Now the 1's complement is 1 1 1 1 0 1 0 1. And what is 2's complement? I have to add plus 1 to this number, so it becomes 0, carry over 1, so 1 1 0, then 4 ones. So this is for -10. Okay, now these two numbers, it can be added up over here. So when you add it up, you can clearly see -5 plus -10 is going to be -15. So you will have, the answer is also in 2's complement form. So when you perform 2's complement, so what is the 1 1 1 1 0 0 1? Okay, so give me a second. So the result for the answer is, it is 1 1 1 0 0 0 1. So this is in 2's complement form, so just subtract 1 from this. So if I subtract it, it will become 1 1 1 1 0 0 0 0. Take 1's complement. Okay, so when you take 1's complement, it will become 0 0 0 0 1 1 1 1. So what is the answer for this? Okay, so you can have an answer like this. 4 ones are there, so you can have 1 into 2 power 0, 1 into 2 power 2, 1 into 2 power 1, 2, and 1 into 2 power 3. That is 1, 2, 4, 8. So which will be of 15. So it is in 2's complement form. The answer is it's going to be minus 15. Okay. So the answer is minus 15. Okay. So similarly, we are going to see the next example. So I'll rub it off everything. So the answer will be updated it. Okay. Sorry, it was wrong. So it is 0. So when you add it up, you will get the answer as plus 5, and you can see it is in positive. Remove, just don't consider the carry. We can avoid the carry, so you will get answer for this process. So this is for adding up of two negative numbers. So the next number is going to be plus 5. It is going to be plus 5, which is subtracted with plus 10. So this we will replace it with addition. So we'll bring minus inside and plus outside. So it becomes plus 5 plus minus 10. So you can see we have plus and minus. So when you subtract, you know that the answer is going to be minus 5 over here. So the answer will be in 2's complement form. Just add it up, you will get the 2's complement form and convert the 2's complement form into answer. So how do you convert it? The 2's complement result is, so we got the result as 1 1 1 1 0 1 1. So first subtract 1 from this to get a 1's complement. So this is 1 0 1 0. So this is 1's complement. Take 1's complement for this, so you'll get the answer. So answer will be 0 0 0 0 0 1 0. So the 0 1 0 is going to be 5. So it is minus 5 is the answer, okay, for your process. So how do we do it? When you try to subtract two positive numbers, make one number as a negative number and perform it as addition. Next one is, I have topmost is positive and the next one is negative. That is, I have plus 5 subtract with minus 10. Okay, so this I will convert it into plus 5 plus 10. So simple, I just add 5 and 10 to get the answer, which will be 15. So this minus and minus will become plus. So this is what the constraint. So it's a normal addition. So if you have in this format, the second value will be made as positive and the answer will be taken as process. So next thing is, we'll see some worksheets. Okay, so I have given all the things. So I will provide you worksheet at the last. So with this, we are coming to the end of the number system. So the last topic is about the binary coding system. So where do we use a binary coding system in the computers? What are the general coding systems we are used? We are using an extended binary coding decimal interchange code, that is EBCDIC. And next one is the binary coding system is ASCII, American Standard Code for Information Interchange, which is widely used in all the computers. And the last one is Unicode. So you see first one, the extended binary code decimal interchange code, the coding system. It uses 8 bits. 4 bits will represent a zone and 4 bits will represent the digits that is to used for representing a data. So it can have maximum of 256 combination to represent all the data. So this is widely used. It is mainly used in mainframe computers. Okay. So you will have only 256 combinations, and with that 256 combination you will be working on it. So the next one is the American Standard Code for information interchange, which we call it as ASCII. There are two types of ASCII formats we have, ASCII 7 and ASCII 8. What is ASCII 7 is you will use 7-bit combinations, in that 3 bits for zone and 4 bits for data. Maximum you can have 128 combinations to represent the data. So which is extended, which is mainly used by IBM, which is converted into ASCII 8, which is then extended version of ASCII 7. Here we will be using 8-bit code, and 4-bit is used for zone and 4-bit is used for data. So here you will be having 256 combinations. So this is a widely used in all computers. So from the symbol 0 to 31 you will be using for control characters, and 48 to 57 will be used for numeric, and 65 to 90 and 97 to 122 is used for uppercase and smaller case letters. The remaining codes are used for extended ASCII code values, which are used by the special computers. And the last binary coding system is Unicode. So Unicode character, which is representation of text, includes letter, numbers and everything. Here we are using 32 bits. That means nearly 4 billion combinations, which used to represent all data of any language, Latin, Japanese, Hindi, anything is done with this language. Is Unicode is an compactable. It is compatible with the ASCII values also. It can include ASCII combinations are recognized by the Unicode also. So that's all about the number systems that are used in computers. Thank you. We'll be seeing a new topic in the next class. Thank you.